Welcome to this video blog. I would like to show some easy linear models that TILOS uses to calculate tasks. At the beginning, let me introduce that little sample schedule. Beginning at a certain date defined by these milestones, two buildings have to be constructed. One on location 3000 meter and the second on location 1000 meter. Building A is on the right side and building B on the left side, so the working direction is defined from right to left. The two buildings are already connected with a dependency link. Both will be created from the same team, so building B can start when building A is finished. Now comes the task that is important for us. Before the buildings can be created, there has to be a drainage created first connecting those two buildings. I create that drainage task by drawing a lineage task from 3000 to 1000 meter. The task could be changed to any duration in a graphical way. But now we want to calculate this task's values in order to estimate the execution time or speed. The linear calculation models are the top three ones in TAP calculation. Calculate the quantity, the work rate, or the duration. Having selected the calculation work rate, we can first set up a fixed quantity for this task. As it goes along 2000 meter, the quantity is 2000. I fill the value in the field quantity here. Look what has happened. The work rate now shows the rate between quantity and duration. Here it is 181 and something meters per day. Any change of duration will change the work rate. So I set the duration to 10 days. Now you can directly see it takes 200 meters per day now. If I use a smaller duration, the work rate gets bigger, and if I use a bigger duration, the work rate gets smaller. Any change of the quantity will change the work rate too. If I make a smaller quantity, the work rate gets smaller, and if I take a bigger quantity, the work rate gets bigger. This calculation of work rate can be used for checking what work rate must be done for a specific combination of quantity and duration. With this work rate, you may decide what machine or crew you have to send to the execution, that the task is done in the predefined duration. Following, we change the calculation model to a duration. The duration is now fixed and calculated. The work rate is now open and taken from the field planet work rate. Any change of the planet work rate will directly change the duration of the task. So if I take a bigger work rate, the duration is shorter, so the task is finished earlier. And also any change of the quantity will result in a change of duration. This calculation of duration is commonly used for estimating the duration of a task based on the construction speed of the leading resource. The following sequence will bring the single task calculation in context with the schedule of the two buildings. Each of those buildings can only start when the drainage is finished in that section. So I connect the drainage at the start with the start of building A, and at the end with the start of building B. Additionally, the preliminary works are a predecessor for the drainage. In our first case, the planet work rate is 200 meters per day. The reschedule of the project shows that there is no change of any date of the buildings. Now what is happening when we are working slower at the drainage? If we set a work rate of 100 meters per day, you can see that the building B has to start later to avoid a clash. The reschedule process of TILOS will do this. These are the most easy but useful task calculation models. More will come in future video blogs. Thank you for watching.